As you remember from the last video, the Earth began its history in extreme conditions. But no matter what, she did it. Pierced, exhausted, but stubborn, she persevered. And soon it gave rise to the most important event in her history, the emergence of life. But how and where could life have originated? We'll figure it out now. Hot springs and the beginning of the chemistry of life. South reservoirs began to appear on the early Earth due to condensation in the atmosphere. Gradually, the water cooled the hot surface of the planet. But under this water, Hell's Kitchen was still raging. There were volcanoes at the bottom of the reservoirs. They released hot water saturated with hydrogen sulfide, iron, manganese, and other minerals. The temperature reached 400 degrees Celsius. Chemical reactions took place between the hot water from the volcanoes and the cold surrounding water due to the difference in temperatures and concentrations of substances. These reactions may have been the first steps towards life. This is where catalysts come into play. Substances that accelerate reactions without spending themselves. The theory of a warm pond. Imagine shallow bodies of water on land. The sun is shining and ultraviolet light triggers chemical reactions. This is how amino acids, nucleotides, and lipids could be formed. Does it sound like something out of a textbook? Let's keep it simple. Amino acids are like building blocks for building proteins. Squirrels are the house itself. Nucleotides are like letters in a DNA book. They store information about how the body works. Lipids are fats. It's like fuel for our cells. The role of clay and volcanic glass. But it's not all about ultraviolet rays. The clay and volcanic glass in these ponds supposedly help the molecules meet, come together, and react. Imagine that it's like a desktop where everything fits into place, conveniently and efficiently. The theory of cosmic origin. There's a second hypothesis, the cosmic origin of life. Meteorites, comets, asteroids, they could also deliver organic matter to Earth. For example, the Murchison meteorite, or Murchison, whichever is more convenient, contains amino acids and nucleotides. These space packages could become a launch package for life. The first organisms, bacteria and archaea, single-celled organisms gradually began to appear from simple molecules. Why them? Because they are simple, stable, and know how to clone themselves. Imagine, there is one brick, and it can make copies of itself. It's very convenient, isn't it? The conditions on Earth back then were anaerobic, that is, without oxygen. It was in such conditions that bacteria and archaea, the oldest forms of life that are still with us, began to develop. They are like a living memory of the very first steps of the Earth. Protobionts are the ancestors of life. Scientists suggest that there could be protobionts in front of real cells, vesicles surrounded by a membrane. The conditions for reactions were created inside them. It's like a small laboratory where molecules hang out and try to interact. So, we have moved on to a new stage, the Archean era. It lasted from about 4.5 to 2.5 billion years ago. It was at this time that the great journey of life began. But the story doesn't end with unicellular ones. The Earth continues to evolve, and we will definitely show it in the next video.